Okay. There's one viewer. Is that you, Xander? I'm so sorry. I went to Bateau Bay. I went for a run at the beach, and I got back, drove into my garage, checked my phone, one email. No, checked my phone, one email, and then it was from you. I was like, what's Xander messaging? That's random. And you were like, oh, are we doing the thing? And then I was like, oh my god, I totally forgot. And that was like 10 minutes ago. So I like sprinted upstairs. I apologize if I keep coughing, but my run was very hard and I'm very tired and I forgot all about this, so I apologize. But we'll go through it. Let me get my breath back. Alright. Music. Let's see if is everything good. Excellent connection. Sweet. Okay. We'll do 2 or 3. I don't know how many, but I've got what 5 here. I might just do these 2, and then do these 2 next week. Alright, let's do it. Steve and Jess, 2 students. They agreed to take part in a psych experiment. Mic check. Each has to answer a set of multiple choice questions. Each set has the same number of questions. They don't tell us how many. They just tell us that it's more than 20. For each question, there's 4 possible outcomes, A, B, C, or D. Remember that question where it had 5 multiple choice, and you worked it out as if it was 4 unless I made a mistake? Good times. Steve decides to guess every answer. Okay. Let the random variable be X. Steve answers correctly in any particular set. What's the probability that he'll answer the first 3 questions of this set correctly? 1 mark. Use the fact that the variance of this to show that n is 25. Okay, those 2 should be easy. I think the third part's the band 6 part. So if I want to, what's the probability that the first 3 answers are correctly? Well, these are going to be all independent of each other because he's just guessing. So really, it's just going to be 1 and 4 to the power of 3 is what I'm thinking. Okay, so the probability of 3 correct, or the first 3 correct, should be, was there 4 options? 1 on 4 is a pair of 3. What's 4 cubed? Yeah, 1 on 60, thank you. Worked out for me. Yeah, that was A. Whew. Okay, B. What was B? Where'd that go? Oh, it's AI. Wow, okay. Use the fact that the variance of X is 75 on 16. Okay, so the variance of X, I'm pretty sure the variance is on your reference sheet, but, so I've just got my reference sheet down here. It's NP 1 minus P. Okay, so they've told us the variance is, I've already forgotten, what was it, 75 on 16. So 75 on 16 is equal to, now N is what I don't know. What am I trying to find? Am I trying to find N? Is that, yeah, show that N is 25. Oh, they've given us the answer, how nice. N, our probability is still a quarter. 1 minus our probability is 3/4. So that's, wow, this is really nice. That's 3 on 16. If I now divide, that's going to be 75 on 3, which is 25. Wow, n equals 25. That's definitely the band 5 question. Band 4, 6. What am I saying? Okay, B. Let's go to the band 6 part. Hopefully. The probability that Jess will answer any question correctly, independently of her answer to any other question, is P. Okay, so she's not guessing. They're saying that this is her probability of getting it right based on, I guess, her knowledge. Let the random variable be Y. The number of questions that she answers in a set of 25. Okay, so they've told us n's 25. If P, Y is greater than 23, is equal to 6 times the probability that she gets the last question, or that she gets question 25 right. Show that the probability is that. Okay. No comments? No Chloe? I've already forgotten what it is. P y greater than 23. P y greater than 23 is, was it equal to 6 times P y equals 25? Is that what it said? Sounds easy enough. Yeah, I was thinking that. I don't know why this is... I don't know. Is there... What question is it? It's from this. I don't know what that is either. Maths Extension 2? From somewhere else? 2012? I don't know. Okay, well, I guess the first thing we can say is that... I guess we can rewrite this as P y equals 24 plus P y equals 25 equals 6 by P, whoops, my hands are freezing, 25. That makes sense, yeah? If that was greater than that, I have the 23, but I don't. Okay, so, oh, missed a bracket. I can move that, because they're the same, so I'll move that over, make it a minus, and that's 5. So Py equals 24 equals 5Py equals 25. Is that alright so far? Sounds easy enough. Okay, alright, guess that's as far as I can go with that so far. So what are we looking at? We've got y is binomially distributed, n was 25, and what are we trying to do? We're trying to show p is that what it says? Yeah, show p is 5 on 6. So we don't know what p is. Sorry, just getting messages. Alright, well, I guess we can write what each of them are. So Py equals 24 is equal to... what's the binomial theorem? Do you know that off by heart? Because I definitely don't. It's... I'm just going to write it blank for a sec, so I can fill it in. Y equals y is ny Py 1 minus p and minus y. Okay, let me fill that in. So 24. So n is 25, so that's 25, 24. P 24, 1 minus p, 1. 25 minus y. Is that right? Okay. P of y equals 25. I don't sound like I'm underwater. I know off by heart, but it's on, yeah. Sorry, I've got, underneath my face, I've got the reference sheet. So you can't see it, but I can. Okay, so that's 25, 25. P 25, 1 minus P, 25 minus 25 is just going to be 0. Okay, so let's set them back equal to each other. What's 25 choose 24? That's just 25, isn't it? Let me just make sure of that. Yeah. Okay, so I'm going to use this line. So that's 25, P 25, oh whoops. Look at the top line, 24, 1 minus P equals 5 times. 25 choose 25 is 1. P 25, and then that whole thing down to 0 is just 1, so that's that. Okay. Let's divide by 5, so then there's a 5 here. Let's divide the P out. The P25, P20, there's so many numbers. So that's just P, 5, 1 minus P. Is that right so far? I feel like I've done something wrong. Have I not? Did I do that right? That went, and then that went. Okay, let's just expand this. 5 minus 5p equals p. 5 equals 6p. P equals 5 on 6. Was that the answer? Is that what we wanted? Wow, I don't think that's a band 6 question, eh? Some of these have been kind of easy. Oh well. Pretty sure the next one is there. 5. Alright, what was 5? Wow. Ones where it doesn't give you any values, they're the real fun ones. The diagram shows, okay, it shows x squared, and the line y equals h, so I guess that's that. H is greater than 0, yeah, obviously. It's rotated about the y-axis. The point C is the intersection of these two. H has the coordinates. Okay, so it's just telling me what the drawing has. Actually, let me put it up here. That makes more sense. Now I can read it. Find the exact volume of the paraboloid in terms of H, and then what's the ratio of the volume of the paraboloid to the volume of the cylinder? Okay, yeah, right. I'd gladly accept it as a band 6. Yeah, so would I. Have you gone through the last year's Extension 1 exam? Because that was meant to be the hardest out of any courses exam in the HSC. So I'm curious if you thought it was hard or not. Yeah. What was I doing? Question 5. Okay, so I've got, let me just draw this thing. Let's, actually, do I need that? Find the exact volume. Now let's just, yeah, so the volume is, what am I looking at? A parabola, what way is it rotated around the y-axis? So that means pi between A and B, is it x squared? X rotates around y, d, no, it's y, yeah, hang on, whoops, where'd that go? Oh my god. Call that dy. Now y equals x squared. Oh, so I don't even need to change anything, so that's nice. It goes from 0 to h. So from 0 to h, y, wow, okay. Not yet, yeah, okay. From 0 to h, is that it? Can I just start working through if that looks like it? Yep, okay. Integrate that, a half y squared from 0 to h, that's a half h squared minus 0, so that's just pi on 2 h squared. Is that it? Find the exact volume in terms of h. Well, that seems, is that loud? That music just went really loud. That seems, is that it? I have volume in terms of h. 2 marks. Yeah, right, okay. I think the next one's going to be a bit of a doozy. Let me move that in there. That was A. Move that. Is that A? Yeah. No, I. I Captain Units. Oh, thank you. Okay. You like picking out my mistakes. The cylinder has radius HC and height H. Okay, let me draw. Let's just draw what the parabola looked like. So it was like that and then like that. If it's, say, HC, so I'm drawing a cylinder. So like that. It's got the radius that, so that means I'm going across, look something like this. Oh, come on, that's a pretty good cylinder, eh? Don't need to be too fancy, I guess. This also doesn't feel like band 6. Let's find out. What's the ratio of the volume to the volume of the cylinder? So I guess we just need to find the volume of the cylinder. Is that it? Okay, so volume, let's call this volume cylinder, volume parabola. It's volume of cylinder, it's pi r squared h. Well, that's nice because my height's already h. Okay, well, what's my radius? My radius is hc. So pi hc squared h. Okay. Need kind of need this in terms of h, don't I? Because I want to be able to compare them. Okay, well, if I want this in terms of h, so that's the point, what's that? That's the point, no, that's, what was the height again? What am I looking at? That's 0h. So I guess I could substitute, well, if my y, hang on, if my y value of x squared is h, then h equals x squared, then this point here should be, my x value should be the square root of h. So that point should be root h. Does that make sense? Hope that makes sense. So that means my radius is root h squared h, which is pi h, which is pi h squared. Okay, I feel like that's kind of it. So then the ratio of, which one is it? Paraboloid to cylinder. So paraboloid to cylinder, oh, no, not equals, ratio. Pi on 2h squared. Can you, yeah, I just don't want to write too low. Dot pi h squared. Well, a lot of things are going to cancel here. That can go. The pi's can go. So what have I got? I got 1/2 1, or just 1.2. Is that it? That seems right. Let's think about that. So the volume of the paraboloid, so spun around like this, is half of the cylinder, which is the rest of it. Does that seem right? I guess it kind of seems right. I think so. Yeah, okay. It's all come down to my amazing picture. Okay, let's do another one. How long have we been going for? 17 minutes. It seems too easy. Yeah, you're right. Maybe we're just experts, you know? I promised these ones to be 6 questions. Let's look at the answers. Where's... Oh, I've got the wrong document. Hang on, let me get the document with the answers on them. Okay, here. That's microscopic, give me a sec. Yeah, look at this, the mean mark for, so the previous question, the 5 on 6 one, the mean mark was 19%. I think 19% of students got that. And the one we just did, was it, yeah, so it's 1.2, mean mark 24%. So people suck at this. Here we go, most common errors, 1, use the correct axis, and 2, check the limits. I feel like the limits was the easiest part, just goes from 0 to h. But the wrong axis. I think it's confusing because you try to square something, but your function is x squared. Maybe that's the confusion. It didn't say what's wrong with this one. Mean mark of the next question is 16%. Oh, that one looks fun. 21%. We'll do that after. Do that next time. Oh, oh, let's finish on combinatorics. That's fun, isn't it? Use the binomial theorem. Oh, great. Let me just use the binomial theorem to find an expression for a constant term in the expansion of that. Yeah, right. Okay. Well, I guess the first thing I'm going to do is write the binomial theorem because I don't know that. Is it A plus B? N equals nk. A n minus k, bk. All right, this will be our last one. All right, what have I got? I've got 2x cubed plus, no, minus 1 on x. How does I say 12? Equals, okay, n on k. So, oh, k is what I don't know, isn't it? Let's write this thing in general. So n, k is what I don't, oh, n is what I do know, idiot. 12k, a is 2x cubed, n minus k, so that's 12 minus k. B is minus 1 on x. What's k? I don't know. All right, let's just work through this. Zoom in on that. Okay, 12, choose k. I don't care about that for the sec. Maybe we expand this, so that's 2 to the power of 12 minus k. X cubed to the power of 12 minus k, so that's 36 minus 3k. Oh, okay, a constant term is going to have this as 0. Hang on a minute, this is x to the minus 1. X to the minus 1 times k, so x to the minus k. Is that right? Or minus x to the minus 1. That needs to be a minus, does it? I'm doing too many steps at once. Minus x to the minus k. Is that alright? Oh, actually, let's bring the minus 1 out. Let's do that. Let's go x to the minus k, and then minus 1 to the power of k. Okay, so now I only care about this part. No questions? Okay, so I want that to be 0. When's that going to be 0? Oh, let's join them first. X. If I'm timesing, that means I'm adding. So 36 minus 3k minus k. This is 36 minus 4k. Okay, so then this equals 0 when that equals 1 when 36 minus 4k equals 0. So that's 36 equals 4k. That means k equals 9. Is that it? Is that the answer? Okay. Yeah, okay. Oh, what is the constant term? Oh, I haven't answered it. Okay. I've just said the k value for which the constant term occurs. Now I need to substitute it. Alright, let's go from here. Equals, so 12 choose 9. 12 minus 9 is 3. X to the, I'm going to use this. No, that's going to be x0, obviously. And then minus 1 to the power of 9. Okay, let's 12 choose 9. I don't know what that is. 12 choose 9. That's 220. 2 to the power of 3 is 8. And then it's going to be a minus. Is that right? So times 8. 1760. Or minus 1760. Alright, that's what the constant term is going to be. That was I. Yeah, right. I. For what value of n does that thing have a non-zero constant term? Oh, for what values of n? Yeah, right. Okay. Well, I found one value. 12. I guess I'm going to have to do the same thing. So 2x cubed minus 1 on x n equals, okay, let me go back to this. 12 choose, no, it's not 12 this time. N choose k. 2x cubed, I hate that 3. 2x cubed n minus k minus 1 on x. Okay. Let's deal with this. N choose k. I hope this is. Can't think of a better way to do this. You just want when that is an integer. Wait, no. Now, don't you want when that's 0? So then you don't have an x term, because then it would just be the constant. Let me keep going with this. So 2n minus k. Oh, I see what you're saying. You just want when, yeah, but that's when it's 12. X 3n minus 3k. Let's do the same thing here. Minus 1k. X to the minus k. What do I want? I want, what value of n does it have a non-zero constant term? Okay. Isn't it just the same thing? Don't I just care about this? feel like, yeah. Oh, 4k. Oh, I haven't joined these two. Yeah, right. So x 3n minus 3k minus k, x 3n minus 4k. So if that happens when 3n minus 4k equals 0, 3n equals 4k, n equals 4k on 3. Okay, is that it? Let's look at the answers. Oh yeah. K equals 3 on 4n. Is that what we got? Oh, k equals 3 on 4n. What? Why k? Why are we... What? What values of n? Isn't it this value of n? K equals... Since n and k must be integers, n must be a multiple of 4. Okay. Well, you can just see that from this line, can't you? N has to be a multiple of 4, even though there's a 3 there, because you want k to be an integer. Yeah. I wonder where the mark would go. Like, if you got to here, would that be sufficient? Like, how many marks is this thing? It's only one. How is it 1 mark? Wow, 3 marks. That's almost half a page of working. Gee, that's a bit mean. Maybe that's why it's band 6. Yeah, I don't know. Okay. Alright, I'm going to stop there, but do you want to have a go at this one? This is what? 1, 2, 3, 4, 5, 6. That's 7 marks. What's 7 times 1.5? That should take 10.5 minutes. Show that that equals 0. Substitute that into there. And then prove that. Holy moly. Yeah, that looks fun. And then what's this one? So we'll do this next Tuesday. 10 carp introduced into the lake. Well, I'd love to know which one's band 6 quality. 1 mark, 1 mark, 1 mark, 3 marks, 2 marks. Yeah, okay. I really enjoy this. This is fun. It'd be more fun to do it face to face, but it's still pretty fun. And I hear that you're allowed to come to school, so that's kind of cool. But yeah, thank you for reminding me, because I would have 100% forgot. So yeah, thanks for that. But yeah, we'll go through those 2 next Tuesday, and maybe even if they're too easy. Like, look at these. What's that? What's that? These look fun. And then this projectile motion one, I can't wait to do that. Alright. Well, have a nice day. I'm going to go have breakfast and probably have a shower. Goodbye.